If you're already a software engineer, then I've got some good news for you. You're probably about 80% of the way to becoming an AI engineer right now, and you don't even know it. Now, here's what I mean. I have a friend. He works as an AI engineer at a pretty big startup. He makes a ton of money, $200,000-$300,000 per year. And when I asked him what his job actually looks like day to day, this is what he told me. It's about 20% AI, and the other 80% is just normal software engineering. So building the systems around the AI models so that they actually work in production. Now think about what that means. The part that everybody's scared by, the AI stuff, is the small part. The big part, which is actually the more difficult stuff, is what you already do every single day if you're a software engineer. So becoming an AI engineer isn't really a career restart here where you're going back to zero. It's simply adding one layer on top of the skills that you already have. So in this video, I'm not going to give you a 47-step, Reddit roadmap that starts with learn Python and go into this and go into that. You already know Python. What I'm going to do is show you the exact gap between where you are now and what you would need to learn to become an AI engineer so you can close that as fast as possible. Let's dive in. So first, let's kill a little bit of confusion because the title AI engineer can mean about 5 different things depending on who you ask. Now, I'm not talking about being an AI researcher. You're not going to be training the next GPT-5 from scratch or really even building LLMs yourself. You're not going to be writing model architectures or reading every single line of, the attention is all you need paper. That kind of stuff is really reserved for the PhDs that know heavy math and have massive research budgets. And honestly, those people are probably a lot smarter than us who are watching this video, including myself. Now that's more machine learning, right? And that's a completely different job than an AI engineer. The role that I want to talk about here is a lot more practical. It's one that has thousands of open job positions right now, and it means that you take existing models, so the GPTs, the Claudes, open source models, whatever, and you build real software systems around them. So you're implementing existing AI into products. You're usually not training your own models from scratch. You're really writing them into APIs, databases, real applications where you use that AI feature. And the reason why this is an important detail is because that's effectively software engineering with an AI layer on top. It's really not a new career. It's effectively what you currently do. You're just adding another layer, which is the AI layer kind of on top of all of the foundations that you've already built. So with that in mind, what foundation do you already have? Now let's go through the stuff that beginners spend months grinding through that you can pretty much just skip, assuming that you already know it. Now first, Python and general programming, right? Beginners spend 2-3 months getting to the point where they can write decent code. If you're a software engineer, you already know that. Git and version control, use this every day, pretty straightforward. Working with APIs, for example, sending requests, HTTP, JSON, again, all of you are probably going to know that. Next, databases. What is a database? How do you query data? How do you optimize it? How do you insert, write basic SQL, etc.? Then we have testing, error handling, retries, logging. Again, probably know that. Docker and deployment. And then something like reading docs and figuring out what it is that you need to do. And here's the big thing that people massively underrate when it comes to kind of AI engineering, and that's system design. So knowing how to take a bunch of moving parts, like what we just talked about, and turn them into something that can run reliably in production for tons of users. That is the single hardest skill in AI engineering. It has pretty much nothing to do with the AI itself. So if you have that skill already, you're already at a really good place, and you just need to learn a few of the things that I'm going to cover in the rest of the video that's related specifically to that AI layer. So what I'm going to do now is dive into all of the topics that you actually need to learn. But before I do that, I know that while you're watching this, you're going to be saying, how do I learn these topics? Well, here's the trap that most people fall into, and that's that they watch a roadmap video just like this one. They watch 10 more, they read a ton of blog posts, and they feel productive because it feels like they're making progress, but they haven't written a single line of code. Now, you cannot passively consume your way into software engineering or AI engineering. The people who actually make this jump are the ones who build things from day one. So pick projects, build stuff that's a little beyond what you currently know how to do, and that gap is the thing that's going to force you to learn. So take an input, send it to a model, do something useful with it, build a cool app for yourself or your mom or your brother or whatever. That's where the learning happens, and that's what you can actually point back to in an interview later to say, here's the thing that I built. And there's data that backs this up. When you just watch tutorials or read articles, you retain about 20% of what you learn, whereas when you learn actively by actually writing code and building real projects, that can jump as high as 75 to 90%. Now that's a massive difference, and that's why for this video, I've partnered with DataCamp. Now, I've used DataCamp for years to sharpen my own Python and AI skills, and their Associate AI Engineer for Developers track is built for exactly the person who's watching this. So someone who can already code and wants to add that AI layer fast. Now, it's hands-on the entire way, where you're writing real code in your browser and getting instant feedback from the very first lesson. So you're not just watching someone else type. And the track maps almost exactly to what I'm about to walk you through in the rest of this video. So it's about 26 hours of interactive learning where you build real applications like chatbots, recommendation engines, semantic search systems, using OpenAI API, Hugging Face LangChain, you name it, it has pretty much everything, and it covers the production side as well, so LLM ops, which most people skip. So you're going to learn rate limiting, API errors, structuring model outputs, etc. And then when you finish this track, you can also take the AI Engineer for Developers certification, and that's a timed exam. It's a 4-hour practical exam where you build a real AI app, and it's a credential that you can put right on your LinkedIn to show that you know what you're doing. Now, I wish that this existed when I was starting out, because it would have saved me months of going through all of the AI topics. Anyways, if you're interested, you can use my link in the description and get 25% off and add those AI engineer skills to your stack in a productive, practical way. So now let's get into the next section, where I want to talk you through the gap, right? So everything that you need to add, and in the specific order. So first, you need a real mental model of how large language models work. And I want to be clear here, I don't mean the math. So you don't need to understand the internals of the attention mechanism or be able to derive any formulas. What you need is a practical mental model. So that means understanding tokens, why models think in tokens instead of words, for example. What is context? What is a context window? And why can you not just dump, 10 billion tokens into a model and expect it to work? Temperature, for example, other parameters you can tune the model and see why you get specific answers. And then things like message roles, so like system, user, assistant, because when you're using these models through an API, you're going to be using those roles. So once you understand these things, you can actually reason about why a model is behaving in a certain way instead of just randomly guessing and pasting in a bunch of prompts. And that's really the difference between someone who knows how to use AI and someone who can engineer with AI. Now, the next step is that you need to actually be able to build with the LLM APIs or frameworks. So mainly the OpenAI API and then the Anthropic API, right? Those are going to be the most popular right now, but there are a ton of other ones. Now, there's a real difference between someone who opens ChatGPT in the browser, right, and someone who can call these models from code and build something around them. Fortunately, they're pretty easy to learn, but you need to understand how to make the call, handle the response, have a multi-turn conversation, and deal with things like failures, because that's going to happen when you use these APIs. And the thing that you need to internalize here is that you can use these models without someone giving human input. So a lot of the time, these models can actually run in the background, and they're not directly triggered by someone typing something into a text field. They're done by you intentionally to kind of engineer a solution. So for example, maybe you fill in a database field, maybe you classify something, summarize a document, whatever. There's a whole pipeline of things that you can do that doesn't just have to be based on a conversation. And when you understand that, it starts to give you a lot of creative ways to make really interesting AI systems. Okay, now the next thing we're going to look at is prompt engineering and structured outputs. Now, I know prompt engineering kind of sounds like a buzzword, but to be honest, it's very important, especially when you need to get reliable results. So what you need to learn here is how to write system prompts and user prompts that actually constrain the model. So you need function calling, for example, where the model returns structured data that your code can use. So instead of just a paragraph, you're getting JSON back, for example, or you're getting a call or a tool output or whatever, right? And the whole goal with this section here is to have reliability. So you can have consistent, reliable output you can actually use in production. With a lot of these models, you can force them to output something in a particular format, and that allows you to handle it the way that your code needs to handle it rather than parsing a bunch of random strings. Okay, now the fourth topic we have is RAG and vector databases. Now, RAG stands for Retrieval Augmented Generation, and it's probably the most in-demand pattern in AI engineering right now. It's been around for a few years, but it's still wildly popular. Now, a huge percentage of real AI apps that you use have some form of RAG. And the concept is very simple. The model was trained on some general data, but your user wants answers about their data or company data or whatever. So their documents, their code base, their company's knowledge base. Now, RAG is how you can close that gap. So you can take that data, you can convert it into something called embeddings, which are just numerical representations of the text, and you can store them in something like a vector database like Pinecone or Chroma. Then, when someone asks a question, you can search through that database, find the most relevant answers, and feed them into the model so it can use those to reason on the answer. So now the model has all its original training data, which allows it to reply or give you some format or something, or some answer, but it also has that additional data that you fed in to get that context from the user. This is probably one of the most useful things that LLMs can do, and that's why it's used all over the place, but it's a little bit more difficult than it looks, especially at scale, so you need to look at how you can vectorize massive amounts of data and query it efficiently. Now, the next thing we need to look at is orchestration and agents. Now, this is where you go from a single API call to an actual system. So the framework here are things like LangChain, LangGraph, temporal, ingest, llama index, whatever, right? These are where they let you chain multiple model calls together, build agents that can use multiple tools, manage memory and conversation state, and run multi-step workflows in parallel across distributed architecture. Now, picture an agent that can serve the web, query a database, run a calculation, and then maybe summarize all of that for the user. Now, getting those steps to work together reliably is the orchestration, right? How do we handle the failures, the retries, the rate limiting? How do we get these steps to actually go in the correct order or do them in parallel? That's the idea here. And this is where things start to feel a lot more like real software engineering, where really you're using normal software engineering tools to orchestrate the AI so that it works reliably in production. And that's what I was talking about. If you're a software engineer already, this is going to feel really familiar. Okay, and then the sixth and kind of final step that you're going to have to look at here is the one that many people skip, and that's LLM ops. Now, that's effectively taking everything that we just talked about and actually pushing it out into production. So you already know about deployment. Now what you need to do is add the AI-specific layer on top here with things we discussed, like rate limiting, right? Because these APIs have hard limits, cost optimization, model routing, caching, for example, because you don't want to keep running the same prompts over and over again. Again, managing the cost so that you don't go out of business, and then monitoring and observability. So things like, how do we get this to be deterministic? How do we know if something's failing constantly? How do we check and kind of see inside of the system to know what the AI is doing? And then things like evaluations, so you can actually measure whether your system is getting better or worse when you change something. Now, this is the part that employers are going to care the most about, and it's the thing that's going to really make you stand out as an AI engineer, because you have the software engineering background, plus you know the LLM ops, so not only can you build the system, but you can deploy it, which is really where a huge gap is right now for those types of users. So that's effectively the entire job here of an AI engineer. If you learn all of those things, you're going to be really well set up, but only if you learn them actively. So make sure that you're actually building projects and that you're doing this, not just reading textbooks or going through videos. Okay, so now that we understand the skills, I want to talk about how to learn these and how to make the transition. There's a few things that will massively speed this up for you. And the first is going to be to build a portfolio, right? So not tutorial clones, but build real projects that solve real problems and prove that you can ship something end to end. So even something like a RAG chatbot, right, that's on a specific domain, that's deployed to a website that uses some real data. Maybe an AI agent with real tools that can go and do things, a semantic search system, right, over a real data set. You want to build something that's not only a good software engineering project, but then has that AI layer. So have a clean repo, deploy it, monitor it, and this is going to give you a lot to talk about in an interview and something that's going to edge out a lot of the other competition. Now, second, and this is the fastest path if you're currently employed already, is to become the AI person on your team. So volunteer to build an AI feature that nobody else wants to own, right? Ship one thing with AI inside of your current company. Now, an internal transfer to an AI role or an AI adjacent role is almost always a lot easier than landing one completely from scratch. So if you can learn inside of your company, even if it's not your main role, but you have some real kind of use cases and experience you can point back to, that's going to make your life a lot easier. And I've seen this firsthand when I was helping developers get these types of jobs. Now, the third thing to look at is to use AI tools to multiply your output. Sounds obvious, but if you're going to be an AI engineer, you might as well use it as well. Cursor, Claude Code, whatever, build your own skills, build your own agents. This is not only going to make you faster, but it's also going to teach you how these type of systems behave, which is going to make you better at building your own. And then the last thing, of course, very easy, prepare for the interview. When I say easy, I don't mean it's easy to do, but it's easy to conceptualize. And that's a whole other video, so I'm not going to dive into it too much here, but understand that you're going to have a little bit of lead code, a little bit of system design, and then some AI specific kind of domain questions or maybe exercises that they'll want you to go through. So that's pretty much everything that I have for you. If you're already a software engineer, understand that you're not starting from scratch. There's actually a small amount of skills that you need to learn. You can learn these quite quickly and transition into one of the most popular and highest paying roles in tech right now, which is AI engineering. Let me know your experience with this and if you have any questions in the comments down below, and I look forward to seeing you in another video.